Alright, so today we would like to prove by mathematical induction that 7 to the n minus 2 to the n is divisible by 5 for all natural numbers. Alright, now the process is the same. It's a three-step process where we'll test the basis for truth, then assume n for k, and then induce k plus 1 and see if it is divisible by 5. So the first thing that we want to do now is to test the basis for truth. Alright, so this is our test for truth. So my natural numbers, I'm going to use 1. It's the first natural number there. So the test the basis for truth where n is equal to 1. So in this case, we're looking at 7 to the 1 minus 2 to the 1. I'm substituting 1 for n. This is going to land us 7 minus 2, which is equal to 5. And you could see that 5 is divisible by 5. Because 5 divided by 5, we get whole number 1, another natural number. Now, so yes, it is true. Alright? So because we are aware that the basis is true, what we're going to do now is to assume, alright? We are going to assume, step 2, we would like to assume that this is true. So we're going to assume that it is true. Assume that it is also true. It is true. So it's an assumption for n equal k. So basically what I'm going to do now is I'm doing like a p of k. So p is going to go, k is going to go where the n is. So it's going to be 7 raised to the k minus 2 raised to the k. Alright, so what we're saying now, this, based on the first test that was true, then this should be divisible by 5. So I'm going to use a variable m, and m would be a natural number. Alright, so any natural number times 5 will be divisible by 5 overall. So I'm using m right now. Now we're going to come to the final part of the deal. And the final part of the deal is that we will now do p of k plus 1. So now is the induction step. So now we're going to induce, right? P of k plus 1 is going to land us 7 of k plus 1 minus 2 to the k plus 1. All right, so what we're looking at is that, so we're looking at 7 of that, and then 2 of k plus 1. What we could do with this now, we could shake off these by using our indices knowledge that this is the same thing as 7 to the k times, I'm going to use this, times 7 to the 1 minus 2 to the k times 2 to the 1, because when you multiply, you add powers of same base. So we're able to take that off. All right. Now, this is going to be a very important part of what we're doing. Now, check it out. Do you remember us looking at that just now? This 7 to the k minus 2 to the k was equal to 5m. Now, therefore, I can use this transpose to get 7 to the k is the same thing as 5 minus 5m minus 2 to the k. So because I'm able to take this from that, I can now introduce the 5m minus 2 to the k for 7 to the k now. So let me write it a little bit out here. So let me start by writing it. So where I have 7 to the k, I'm now going to write 5m minus 2 to the k. So I'm going to put the 7 out front. So we'll have 7 times, which is this 7 to the 1, times 5m minus 2 to the k. Alright, so that's that. Then there's a minus 2 to the k times 2 still. Now I'm going to distribute my 7 inside because I want to get out this. I'm seeing something there. So I'm looking at 35m minus, oh, this is a plus, my bad. Plus, when I go across, is a plus, so this is a plus. Alright, so I made a quick error, everybody. Made an error, I put a minus, there should be a plus. It's one of the common mistakes people make every now and then. Alright, we are all humans, alright? Alright, let's go. So we're looking, so this is a plus, so we have 35m, and then I'll have a 7 times my 2 to the k, then I have a minus 2, I'm just switching these around, and then I have 2 to the k, so 2 to the 1, 2 to the k. So this is what we're looking at right about now. At this part, I realize that I am now able to factorize out 2 to the k. Alright, so if I'm factorizing out 2 to the k, then what I'm going to have inside, I'll have 7 minus 2 inside this. So if I should distribute back the 2 to the k, I'll get back my 7 times 2 to the k and my minus 2 times 2 to the k. Now at this stage, we can now quickly observe to see what we have. This is a 5. So this is 35m plus 2 to the k times 5. That's what I'm seeing right now, right? Now, if you look at this, I am now able to factorize out a 5. All right? I am now able to factorize out a 5. So if I pull out a 5 out front, I'll now have 7m plus 2 to the k. All right? 7m plus 2 to the k. So I have 5 times 7m plus 2 to the k. Where we can say, okay, see, I'm getting my factor, because as you could see, this would have been some natural number, all right, because m is a natural number times 7 is another natural number. 2 natural number raised to a natural number will still get a natural number. So we could say that this is divisible by 5. So I'll say just let L equals, all right, 7m plus 2 to the k. So technically you're seeing where we have 5L, where L is 7m plus 2 to the k. And there you have it, the proof that 7 to the n minus 2 to the n is divisible by 5 for all natural numbers. And thank you for watching, and I hope you will subscribe. Also, you could leave a comment below. Thank you.